There we go. I can remember the mute button. I managed yesterday while moving groceries into the house to pull my back out and wrenched a muscle, literally walking. So that was fun. So I'm a little bit hopped up on ibuprofen right now. Should be okay, but if I'm a little spacier than usual, that's just a heads up. Just yell at me and I'll get back on track. Here we go. So we've made it 1 week. Awesome. Glad to have you folks still here. I think all the assignments were great. Everyone figured out GitHub, which was awesome. It'll take some practice. It's okay. We'll be doing it every week. We'll have a new lab. We'll practice that process. We'll click the link to create the repository. We'll clone the repository to get the folder on our computer. We'll make the project in that folder, and then we'll do the lab, and then we'll commit the code, go to github.com, see the code on the internet, make sure that if you can see it online, I can see it online, and then you turn it into D2L. So it's like a 6-step process, but we'll do it a lot, and it'll start to feel a little bit normal again. Okay, glad you folks are doing all right. Apparently I had an echo for a minute there, but we're doing okay. So still trying this HyFlex experiment. It's still unofficial. There's all sorts of interesting stuff in academia. We have committees and subcommittees and people meeting, and then a Senate that has to meet, and all sorts of fun things that I never knew about. So the subcommittee for academic technology, no, subcommittee for distance learning is trying to formalize a definition of what HyFlex is, what it means, and what it looks like. So this is still, quote, an experiment while we wait for the subcommittee to recommend something to the campus senates, to recommend to the college senates, to then get, okay, sure. Anyway, so it's still an experiment. We've got friends on Twitch. I've got them on this other monitor up here, so you can, if you see me looking around a lot, that's hopefully trying to keep an eye on chat. I miss my home setup where I could have another monitor here, but then you fine folks can't see me who came in person. Not that you'd be sad to miss me, but it's okay. So it's nice to have eye contact. I do miss that from teaching fully remote. That was a little different without being able to see people get the glazed look in their face if I'm going too fast, or if they're just spacing out because it's been too long, we need to call a break. So all the previous lectures then, because I'm streaming here on Twitch, I'll export over to YouTube with one click because it's awesome. They'll go to the lecture archive if you haven't found that yet. So this will just be all the links to the class recordings out on YouTube, which is lots of fun. I've had people say they like YouTube because you can speed it up and they listen to me faster. And I've had people say they like YouTube because they can slow me down and listen to me slower. So sure, whatever your preference is, however that works out, that's great. You can always come back to the materials later out here on YouTube. And then I thought I had a link here in the syllabus. Let me take a look. So if you want to log into the college computers for the virtual desktops, there's this link here. So this will take you to our knowledge base article, which says, hey, here's where you can go and download the Horizon VMware client for your particular operating system. And we don't recommend the web access version. It technically works, but not well, I guess, unless that's changed. I keep looking over at our friend here who, I don't know, do you want everyone to know that you work here? So he has actually been very kind at getting a lot of this stuff set up here. So we've got someone on the inside, thankfully. But generally the full client will work better, and then there's a particular network setting you give it to say you want to use the BLAST protocol, or I forget, it's been a little while. You can even do it on iOS, apparently. I would not recommend programming on an iPad. But if you have an external keyboard for your iPad, maybe you'd be okay. But any just touch keyboarding for programming is probably going to be a little rough. But the virtual desktops will get you the same desktops that you're actually logging into here at the college. If you want to use the college resources, or again, all this stuff here is free. You can download it and install it on your personal devices if that's also your preference. Okay.
Is there an image?
The CIS one.
Desktop, or is it just all...
So there are two. So one is college-wide or student or something, and the one is CIS student. You definitely use the one that's the CIS student one, because that'll have all of our software. Yeah, thank you.
Is it a full download, or is it more? I'm just asking. I use VMware a lot.
So the VMware client is a full download, and then it will just connect in almost like a remote desktop to the college virtual desktops. Yep. Yeah, so you're not downloading an image of a desktop at all. You're just downloading the connection software.
Oh,
All right, so as we move into week 2, let's take a quick look here at our Python book. Again, there's a couple different varieties here. His plain website here will just take you, like the interactive one is really cool if you want to run Python code in the browser. I like this one. It's a little slow sometimes and funky, but it works out really well. Or you can just go and access his book. Why can I remember where the link is here? It's... Yeah, nope, that's his Amazon link. This one, the HTML link is hosted on his site here. We'll take you one chapter at a time. Nothing interactive though, so it's not quite as pretty. These interactive ones are a little bit more fun where as he's giving Python examples, you can go and run that Python code. So like if we take a look at chapter 2 for variables here, this prompt here is what you'll see if you've installed Python. You can run the idle, IDLE here. Idle. So this is what's known as a REPL environment. And I'm actually forgetting what REPL stands for. Let me Google that again real quick. REPL. I think I want definition. There we go. Definition. Read, evaluate, print, loop. I don't know why REPL's in my head, but it is, because I think it's a funny word, I guess. So at this prompt, the triple arrow prompt, you can write Python code, like print hello, and it will, when you hit enter, execute that code. So it'll evaluate the code you've typed in and run it. I'm not really a fan of this prompt. I really like my integrated development environment that does all sorts of other cool things for me. That's why I like PyCharm. But you'll see all of his prompts here, like these quick little, hey, if you just type in print 4, it will print out a 4 for you. That sort of thing. And you can try these sorts of things here at the Trinket console, essentially. And it will show you what's happening here. So that's all the prompts here. That's what they're showing you. So as we start talking about variables, Python is really fun. So if you've programmed with other languages, you'll know that most of them tend to be strongly typed, where you say, hey, I want an integer value, which is a whole number, positive or negative, and then you'll give it a value. With Python, you don't have to do any of that. Python does what's called duck typing, which is a fancy term there. So if it looks like a duck, sounds like a duck, and walks like a duck, it's probably a duck. So if you give it an integer value, it looks like an integer, sounds like an integer, and walks like, okay, it doesn't really work that well. But if it looks like an integer, Python will treat your variable as an integer, which is really fun. So one of the things we're going to start doing is telling Python to store values, right? If the only thing we could do is have it evaluate expressions as we fed it to it, it wouldn't be very useful. So we need a place for Python to store information. So if you read back in chapter 1, some of the extra stuff out of the book there that's fun, nice to know, but not super interesting or necessarily that important, everything eventually in our computers are stored in bits, this binary system of zeros and ones. It's either on or it's off, and we just put certain numbers of these together here, typically in bytes, which come at 8 bits at a time. Again, I didn't make any of this stuff up, but it works out really well. So we'll store groupings of bits together, and a certain number of bytes can be used to store different types of data. All that's very well and interesting. But what that means is if I tell Python, hey, go hang on to this value for me, and I want to use this value later, Python will then go ask your operating system, say, hey, operating system, I need a place to store this piece of information. And by the way, it needs to take up this much space. It asks for a certain number of bytes of memory to store something. So I can say something like my favorite number. And again, depending on your variety of Python, I find this snake casing to be the most popular. So when you name a variable, you give it all lowercase with underscores in between. Some organizations go with other casing formats. Other languages will use other sorts of styles here. So you might see what's known as camel casing, where you do every next word gets a capital letter. So you might see favorite number like this. So every next word gets a capital letter, so it catches your eye, and you see, okay, here's my favorite number is one variable name here. But I prefer the snake casing, and I believe that's still the most popular for Python here, even though some orgs do weird things. We'll say, hey, Python, I want to save something here in memory. I'm going to call it Nope, not my snake Python. Wow, that was supposed to be favorite number. This is what happens when you type and talk at the same time. So my favorite number, and I'm going to use this equal sign. So a single equal sign does not mean equals. We've done a weird thing with programming land. But a single equal sign is known as the assignment operator. It says, hey, take something here, I'm going to give you something, and assign it to the thing on the left. So if I say my favorite number equals 42, and I hit enter, it doesn't look like anything happened. But behind the scenes, Python said, hey, operating system, I need some place in memory to go store, hey, this looks like an integer. I need a place to go store an integer. I can now access the value here by saying my favorite number anywhere I want. I get to like substitute that in. So if I were to say print my favorite number, and the one nice thing with this REPL environment here, if you start typing a couple letters and then hit tab, it's going to auto-complete that. It has a list of all the variables that you have, and if it will give you the first one that matches. If there's more than one, you can keep on tabbing, but you don't want to type more than you have to, right? Good programmers are lazy. We're going to let the machine do as much work for us as possible. So I can just type like my and hit tab, and it will fill the rest in for me. So if it looks like I'm typing ridiculously fast, I'm not. It's the machine doing it for me. So if I say print my favorite number, it'll print out 42. Now notice this is not in quotes, right? Because it's an integer value here. Just when you see things. So if I were to say print 42, it'll also print 42. If I were to say print, and then in quotes here, 42, it also prints a 42. At the output, we don't notice whether or not it is a string value here, right? Strings are just a bunch of text here, right? A bunch of characters. This is what we did last lab. You put a starting quote, you put an ending quote, either single quotes or double quotes. I guess single quotes are really called apostrophes. Right? In a set of apostrophes or a set of quotes, you put some text in there, and Python says, oh, sure, it's a bunch of text. Bless you. And generally it lights it up, you know, in green or whatever your IDE color is set for here. Now, Python is halfway decent at doing arithmetic, right? So if I wanted to do something with favorite number and change the value of favorite number, right? I could say my favorite number, and I'm going to use that assignment operator, and I want to change the value of it. Say, okay, hey, forget the thing that you used to store. So it used to store a 42. We'll say, oh, let's change that to 10. Okay, sure. And then I can now print my favorite number again. Now it'll be 10. So a variable can only store a single value at a time. I'll warn you, later on when we talk about other types here in Python, there are types of variables that store multiple things. They're containers. But a variable is still storing one thing even if it's a container. So if I give you a laundry basket, you're only holding one thing, right? If I put a bunch of laundry in the laundry basket, but you're still just holding the laundry basket, you're still holding one thing. It just contains other things, right? So we'll look at that type later on in a couple more weeks. But when I say a variable can only store one value at a time, it's true, even if the thing that it's storing is a container. Okay? So I lost the 42 when I said, let's assign it the value of 10 here to my favorite number. Okay? We can also do arithmetic. I could say, hey, my favorite number, let's assign the value of 10 plus 32. Right? What's going to happen is everything on the right will get evaluated, then it will get assigned back to the left. So I'll get 10 plus 32, and if I print my favorite number again, oops, parenthesis there. Sorry, I missed my closing parenthesis. I'll get 42, because 10 plus 32, right? This works out. Now, apparently, all you young cool kids don't use Facebook anymore because that's for old people like me, even though I'm a millennial, and it hurts a little, and you're onto cooler technologies. But I'm familiar with Facebook, and all these crazy things go around on Facebook, like, here's a math problem. People argue over what the right solution is, what the right answer is. Those drive me nuts. I'm not a math major, but I do like math, and computer science tends to use a fair amount of math. Not heavy, not crazy amounts of math, but a decent amount of math. And they would say something like, hey, what is the value of, we can just print this out. We can say, what was it, 3, and then it was going to be divided by, and then, no, it's 9 minus 3 times 2 or something, I don't know, plus 1. I forget the whole sequence here. And there's more interesting sequences here. And a lot of people, not everyone, but a lot of people would say, oh, okay, 9 minus 3 is 6. 6 times 2 is 12. 12 plus 1 is 13. And they make me cry because we learned PEMDAS, please excuse my dear Aunt Sally, or whatever they say nowadays here, which means you have to do your order of operations, right? Parentheses first. Well, the whole thing's in parentheses, really, because it's inside of print here. So there's no other parentheses to deal with. Then exponents. There's no exponents. Then multiplication and division. Now, here's where people will still argue with me, and it drives me nuts because you're all in college now. I shouldn't have to have this argument with people. But just because you say multiplication first does not mean it happens before division, right? Multiplication and division have the same level of precedence, so they operate left to right. Well, there's only one of them, so sure, we get 6, right? Then addition and subtraction. And again, you don't do the addition first because we say addition first. You do addition and subtraction in order left to right. So we get 9 minus 6 plus 1 should be, no one's brave enough to say it? 4. 9 minus 6, 3. 3 plus 1, 4. Okay? Right, that one's not so bad. But then you do things like print. I think this is the one I got in trouble with my wife because I told my father-in-law he was wrong. Apparently that was not the right move. And it doesn't really work in Python, thankfully, but that's okay. It was 9 minus, what was it? 3 times 2 or something like that, divided by 2. How did this one go here? I think it was this, 9 divided by 3 times 3 plus 2, something like that. Now, this is just a shortcut, right? In math land, you can get away with not having an operator, right? If something touches, in math land, we assume it's multiplication, right? You can't actually do that in Python. Python says, no, and it gives you some funky error here. But what that essentially means is 3 times 3. So we get 9 divided by 3 times 3 plus 2, right? And you don't do the multiplication first, just because we say multiplication and division. Everyone's shaking their head. Yes, right? They have the same order of precedence. So we'll do the division first because it's on the left. Then we'll do the multiplication. So 9 divided by 3 is 3, times 3 is 9, plus 2 should give us 11. Right? Now, weirdly, we get a 0.0. Sorry, it's moving down a little low here. Wow, my backpack's in the way, sorry. Let me see if I can't move that up a little. You get a 0.0 that we haven't had before. Right? When you start doing division in Python, there's a chance that you might get a floating point number or a number with a decimal place. In Python, they're known as floats, a floating point number. The point can float. I don't know. It's a decimal place. I forget why it's called like that. So you'll see that shows up there. Okay. But again, order of operations. If you want something to happen first, you put it in parentheses. Right? Python will respect that. I gotta scroll. Where's my print now? I just go all the way down. There we go. Yeah, let me just make it a little smaller. There we go, because we only need a couple lines, right? So if I say print, if I really wanted to do 9 divided by 3 times 3 plus 2, right? Now the parentheses will happen first, right? I feel like I spend a lot of time on order of operations, but believe it or not, this still trips people up at the college level, which makes me really sad about our K through 12 education system. But I get math is really hard, and we do math very badly. Like grouping kids together by age and saying, hey, we're going to teach you all the same math, and if you don't get it, you keep moving on because the class has to move on anyway. It's a bad way to teach kids math, and you wonder why a lot of kids hate math, right? Like if you never actually figure it out and feel good about it, and they're like, oh, new topic anyway, too bad. Like, okay, sure. Now we get 3, right? 9 divided by 9 is 1, plus 2 is 3. Okay, just order of operations here, okay? So, yeah.
I was going to say, yeah, I agree with the order of operations, but in readability, you always put the, like you're doing there, you would never put it without the bracket. What I'm saying is, the statement before.
Oh, where we had tried to make them touch?
Yeah.
Yeah, this one here?
No, one up. No. Like, wouldn't it be against like a standard programming? If you did that, that would be like not good readability code. You would just then proceed to standard would be to put the brackets in.
Well, you like put them around this one?
No, around the. Never mind.
Okay.
I was explaining that basically to make the code more readable, you always put the parentheses in.
Yeah, so
So that way,
adding more
people can
parentheses.
quickly get through it.
Yeah, so if you've got some complex notation, adding parentheses, even if it's redundant because Python doesn't care, is always a good idea. Because it'll make it easier for humans to follow. Like, okay, yeah, I see the parentheses here. I know this will happen first. Rather than, wait, let me think about order of operation here. Because honestly, people are bad at reading stuff. Like, happens all the time. Like, we can't even proofread our own English papers without missing typos. So adding more stuff to our code to make it readable is fantastic. Definitely. Okay. Other cool things about Python. So like we said, I've got this my favorite number thing. My favorite number. So at this REPL environment, you don't even technically need to say print. If you just give it the variable name, it will print it for you because that's sort of what you do with these REPL environments, this idle tool. In our development environment in PyCharm, if you just put the variable name, it won't do anything. It will just be there. You're saying, hey, go get the value stored here. Now, other things Python tracks about variables, which is cool. So this is showing you some of this built-in stuff. So there's a thing called type. So I can say type of my favorite number. If I do my parentheses right, it will tell me, hey, it's a type of int. The class is int. Int is short for integer. Drives me nuts that we don't use the full word integer, but that's okay. Programmers are lazy, and int is pretty well descriptive of integer, so that's okay. And then it also has type and, what's the other one here? Let's type. I think it's ID. Yeah, it's ID of my favorite number. My favorite number. So ID is an internal storage identifier behind the scenes for what does Python know this as? Everything gets an ID. We don't care too much about that. Not all that interesting. Later on, near the end, we'll talk about when ID will matter. But most of the time, we don't care. Not too big of a deal here. So if you wanted to ask Python if something equals another value, right? We said the assignment operator, right, was a single equal sign. If I wanted to check, hey, does it equal a particular value here? You'd use a double equal sign. This means, does it equal something, right? And you'll either get back yes or no. So does my favorite number equal 42 is true, right? So the double equal sign is the check for equality, equals. A single equal sign is the assignment operator. Okay, so just keep that in your back pocket. Gets a little confusing occasionally, but not too big of a deal here. And it will generally tell you. So if we're using PyCharm, it's pretty good about telling you you've done a weird thing here. This idle is not so helpful, right? We don't get lots of good error messages out of idle. Another reason I'm not a big fan of it here. But let me fire up PyCharm, and we'll start writing some code in PyCharm here. Idle's fun because you can just keep on going. You can just try stuff, and it will run it like that. You don't even have to right-click and hit run anything. You don't have to keep a file around at all. So it's a quick little way to tinker with things. All right, so I've got my lab 0 that I did. So I'm going to go start a new project up. And for me, I need to make sure I put it in the course GitHub repository. So I'm going to click the Browse folder and go find our CIS 2131 folder for summer of 2022. Now, I don't want it right in this folder, though. I'm going to put another folder here. So for you folks, you'll get one repository for each lab. You don't need to have a folder inside of that folder if you don't want to. But I don't want to have to give you 15 different links, one for every week of the class. So I'm just going to use a single repository for everything I do up front. So I'm going to put all of the things I do into folders so that it's easier to find when you go look for the examples here. So this will just be, do you want them by week? Should I call this week 2? Is that an easy way for you to find it? Okay, so I'll make week 2 here. And we'll do that in this current window. So then in my GitHub client, fire that one up. And it gives me my main file. Yours should have one already from the template I use with the GitHub Classroom thing. And we'll just print, again, hello world for fun. Yeah. A new project? A new project in PyCharm?
Yeah.
You go to File, a new project?
Oh,
that's all right. Let me just give it a run real quick. This should always work, but I'd like to sanity check things because I've been messing around. And it prints hello world. Right? Life is good so far. And now when GitHub ever launches, I thought I told it to launch. Maybe it's just being slow. I should be able to see the hello world here. Oh, there it goes. Yep. I'm just not being patient. I'm sorry. And I'm killing my poor computer. Wow. Is it really like that hard? Yeah, running out of resources. Come on, computer. I have a new one. I just haven't installed everything on it yet. I've gotten a little busy. Come on. Maybe. So to pick a different repository, you just go to this current repository dropdown and you can change between, so each of your labs will have one, each of your projects will have one. Bless you. I'll find my 2131 repository. Maybe. Hector, my friend, thank you so much for donating those bits to the Student Scholarship Fund over at the University of Michigan Dearborn College of Engineering and Computer Science. And why Paladin? This is so cool. The internet is such a fun place, as long as you have decent friends. Stay away from trolls. You don't want the trolls, but we've got some decent people online, and just by being here on Twitch, money can get generated for the Student Scholarship Fund, which is super cool, because college is way too expensive. All right, we'll see there's a bunch of new stuff, right? So all of my stuff is in week 2. Anything in the .idea, you can just ignore, right? That's all the PyCharm files. There's leave them alone here, but you'll see the main.py, your Python script here, should actually have some Python code. So committing here will make a copy to your local version of the repository, the one on your computer. So we'll say week 2 started. I'll commit, and then pushing now will take my changes from the local repository and synchronize with the cloud, the central repository, the origin repository on github.com. Of course, I'm not even like maxed out on CPU. I mean, OBS takes a decent amount, but not anything crazy. All right, and then I'll push to synchronize. And again, your favorite shortcut is going to be view on GitHub will launch the web browser to go out and look at this online. Because if you can see it on github.com, I can see it on github.com. I've had people turn stuff in where their code's not on github.com, and then I look at them really confused and say, well, why did you turn it in? Because you didn't see your code there. And they're like, I don't know, I gave you the link. Like, that's your sanity check, right? You're making sure if you can see the code there, I'll be able to see it there. If you don't see the code there, I'm not going to see it either. So you're going to see all this stuff here then in week 2, right? Will be the week 2 folder. You can open that one up. And let me zoom this in a little bit here. Then you can see main.py. Again, just ignore the idea folder. Just let it be. And you can see Python code. Again, nothing super interesting yet. We haven't gotten very far yet, but we're working on it. We're going to do some fun stuff today, hopefully. Or at least I think it's fun. Whether or not you think it's fun, you know, that's up to you. All right, cool. So we got our first Hello World out there. Again, haven't done anything really new from last week, but just going through that process again. So now I can start actually writing some code and storing some values out here. Right, so I can say, hey, I want my favorite number to equal 42. And if I put a double equal sign here, right now it's upset with me, and it says unresolved reference my favorite number. What that means is I've never told Python make something called my favorite number and store a value. So you can't use it until you've named it. So you have to name it before you claim it. All right, sorry. So now I can say, okay, equals 42, and it's okay with it. Then if I want my favorite number, so instead of the tab just being kind of magical, as you start typing, it's going to suggest variable names here. So it says, hey, you've got this variable named my favorite number. If you want it to finish typing that, you just hit tab or enter, and it will finish typing it for you. Right? So variable names should be descriptive and meaningful. They should tell you, the programmer, what that variable is doing. Python could care less, right? You can have a variable named A and store the value of 123. Python doesn't care that it's called A, right? variable names here are for people, right? The reason we write code, first, is so people can read it. Second, the computer can read it, right? Because if you write code that people can't read, by the way, you're people, right? You are people. So when you write code, you might not remember what it means when you come back to it after lunch or the next day or the next week, whenever you get a chance to work on this project again. And if you can't understand what you told it to do because you used a variable name like A, B, C, D, E, F, G, we're going to have no clue here. We got no luck here. So use a descriptive variable name so that you and other people, right, and particularly in the academic environment, other people is also me. I need to be able to read your code and understand what it's doing here, right? So think about you being able to understand it and me being able to understand it. And then when we get to our final project, if you want to work with a partner, making sure your partner can understand it, okay? So we're going to use nice descriptive variable names. Now, there is such a thing as too long, right? Like if you're running off the screen with like, here's my really interesting variable name that stores the distance between so-and-so and so, like you've gone a little too far, right? There's a balance there to be struck here, but you want it to be meaningful and useful. So generally we'll stay away from acronyms or initialisms unless they're very well known, right? Like kilograms, if you're doing like, here's the weight of my kittens in kilograms. KGS is probably okay because you know it's already related to weight. If I just said, here, as I'm like, this was, I think they were, what do they clock in at? 0.35. Took the kittens to the vet before class today, the 3 that we found, so pretty cool. So this is probably pretty meaningful. You know what that means, but if I said like kitten KGS, what is a kit KGS? Like that is not very helpful, right? So if you're including some sort of an initialism or acronym, as long as like you're relating it somewhere, you're probably okay. I mean, really, kilograms is only like 7 more letters, kilograms. So it doesn't even really hurt to type out kilograms instead of KGS, because most people here in America have no clue what the metric system is and how it works because we're dumb and we use our awful imperial system, which makes no sense, and it's not powers of 10 and drives me crazy. I have to explain stuff to my kids like, why is there 5,280 feet in a mile? I have no idea why. I know there's 1,000 meters in a kilometer because it's a kilo, 1,000. Like, okay, I get off on weird tangents. I'm sorry. I have opinions, so. All right, so weight of my kittens in kilograms. So really this should be like kitten 1. I got 3 of them, little kittens, but sure. You know what that one means. And again, it's a long variable name, but I'm not typing it out myself. I'm typing WE, and it says, oh, do you mean weight of kittens? And I'll say yes, and hit tab, right? You don't have to type it just because it's really long. That's why we use these tools. These integrated development environments do this work for us, okay? Yeah, that's Smrta counter. If you have to deal with classmates using terrible variable names, it is awful. Really hard to get work done if you have no idea what their variable names are. And I like to tell people, in the software world, you're going to keep working on your skills and getting better and better and better as you go. Like it's a fantastic field because you're always getting to learn new things. And as you learn new things, you're probably going to get better and better at what you're doing and move on to more interesting projects, right? When we start off with easy things because we're junior developers, right? We're new to the field, and that's okay. We're going to start off with the basic stuff. But as you get better and better, you'll move up and move around, and you'll take different jobs because companies don't pay for loyalty anymore. So like you should be moving every couple of years at a minimum. Otherwise, you're going to lose money because you can get a better salary at another company faster than you can get raises at an organization. So as you move around, you'll increase your salary. That means other people are left to take over your programs, right? So in this idea of the software development lifecycle, which you can go take our software engineering class to learn more about, the bulk of a software's time in the world lives in while it's being used, its maintenance phase or production phase, while people are actually using it. You might spend 6 months working on a project, but if you spent 6 months writing some code and it only gets used for 3 months and then thrown away, that's a big waste of money. And most companies don't like to waste money, right? Most companies want to like get a return on their investment. So that code that you wrote will be existing long after you're there maintaining it. So someone else will have to be in charge of making your code stay up to date, do little fixes and changes and making it do bigger and better things here. And the chances of one of those people being a psychopath and coming after you because you did very terrible variable names is not 0. It's very low, yes, but not 0, right? So think of other people when you write code and write variable names to make them nice and descriptive. It's a crazy example, I apologize, but it got the effect I was hoping for, and a couple of people giggled, so thank you for that. So good variable names, okay? So we've seen integer values, we've seen floating point values, or floats here. So like if you were to ask Python the type of a float here, so if I were to say weight in kilograms was like 0.35, and then I were to say type of my weight in kilograms, right? It's going to tell me that is a float. So float is the official type in Python for a number with a decimal place, okay? Now we can also do arithmetic if we want. So I could say, hey, what is the weight in kilograms times my favorite number? 14.7. Sure, not super useful, because what does my favorite number have to do with weight in kilograms? But right, Python will do arithmetic across types. So just because one's an integer and one's a float, that's fine. Python will say, okay, you're taking a float times something, you're going to get a float back, right? And 14.7 is a floating point value, okay? When we saw you took an integer and you divided by another integer, some languages will do crazy things. Java, I'm looking at you, will do integer division and say, oh, you want 7 divided by 2? It must be 3. And you get really confused because 7 divided by 2 is 3.5. But Java says, oh, you took an int divided by an int, you must want an int result. Python doesn't do that, right? Python says, oh, you took a number divided by a number? Let me give you the right answer. So we like Python. Python's really nice. So if we were to say print 7 divided by 2, right, we'll get back 3.5. Life is good. If you really want integer division, because you want the whole number, and then you also want to get a remainder out for some other thing here, you can say print 7 divided by / 2 is integer division, or floored division, right? Any decimal remainder gets thrown away. So it's how many whole times can I count 2 into 7? This will be 3, exactly, here. Now this might not be super useful for you, but depending on what kind of math we're doing here, floored division is nice. Now the opposite, not even really opposite, but how to get the remainder. How about that? So this is the whole dividends. There's the divisor, the dividend, the quotient, the whole quotient. Please tell, okay, sorry. I do occasionally do math okay. So we have math people in the room, so I'm sorry. But some people are math majors, because Python's a popular language for math. Apparently astrophysics too, which is super cool. So to get the remainder out, next, let me put this back in here, because this will keep it here then, right? So we can say, if I want, so we'll just say print 7 divided by 2. And then in Python, if you put the pound sign, not a hashtag, because I'm that old, so the pound sign. Oh, actually, it's an octothorpe. Someone told me that pound sign wasn't even the real name. And octothorpe is just such a cool word. I remember that. No one knows it's called an octothorpe, though. So if you go around telling people octothorpe, they look at you funny. And I've said it like 5 times now, which is fun. So, but it's a comment. Python will literally ignore this line. Anything that comes after that gets completely ignored here, which is okay. So, so by default, we get floating point results. Default. Did I spell it wrong? I did spell it wrong. Oh, no, it wants a comma. Wow, it even does grammar checking. This tool has like gotten even really smart. I thought it was just spell checking. So, floating point. Now, it's giving me these yellow lines. These are warnings. The Python style guidelines say you shouldn't have spaces around your parentheses. I like spaces around my parentheses because it helps my eyes. So I usually will put spaces there, and then Python will yell at me, and then occasionally I'll go take them back out here because the yellow lines also bother me. So either is okay. So then if you want a integer result, you can print 7 floored division or integer division by 2. Those yellow lines drive me nuts. Okay, and then for remainder, use modulus. So this is the modulus operator. It's really fun. It's the percent sign. So 7 modulus 2 and is what is the remainder of 7 divided by 2. Okay, so and with print, you can actually give it multiple things. Print is really helpful in Python. So I can give it a string here. So I'm going to put in string 7 divided by 2, and then you comma separate what you want to have printed. So 7 floor divided by 2, or integer division 2, and 7 modulus 2, okay? We'll get these ones back out. So if I run this one, we get 3.5, we get 3, and we get 1. Sorry, that's kind of low down there. I can bring that up a little higher there. Right? That's what we expect to get, right? So you get the exact result with regular division, you get an integer result with integer division or floor division, and you get the remainder with modulus. So maybe we should even put in like a colon here or something. I don't know, something nice to make that look pretty. Making output pretty is not one of my specialties. I'm not much of a user interface or usability kind of person. It's not really my skill set. Okay, so we get some results. Nothing too crazy. Now, this might be useful though, because integer division or modulus can be useful if we're trying to like plan a party, right? And if you're planning a party and you're buying a bag of pizza rolls that comes with like 42 pizza rolls in a bag. I have 6 kids and we go through pizza rolls like crazy. And you know that each person will on average eat 12 pizza rolls or more, because my son's 14 now and he eats more than I do. He does eat more than I hate English. I'm bad at it. But he eats more than me. There we go. That's easy. So we can say, hey, if we're going to plan a party, let's go and figure out how many bags of pizza rolls I need to buy. Because you can't go to the store and say, hey, can I have half a bag of pizza rolls? They'll look at you funny, right? So if we say, hey, people attending the party, oh my goodness, so if it's just my family, it's 8 people. Like we haven't even invited anybody over yet. So if we invite some people over, we have a party, we've got like 13 people who come over, right? And then we'll say average number of pizza rolls eaten per person. We'll say each person on average eats what, 12 pizza rolls, right? Sorry, I can bring that up a little higher. Just shout at me if it's hard to see. I keep like seeing people like look down a lot. I'll try and keep it up high. That is this room is bigger than all the F building rooms, so I always reserve this one. But this screen is a little low. So there's also the side screen too, if that's helpful. But then like you're back and forth a lot, so I don't know, whatever works better for your neck. So then if we want to figure out how many bags of pizza rolls, well, I need to know how many pizza rolls come in a bag. So we have pizza rolls per bag. I think is it 42? I want to say it's like 42, and a serving size is supposed to be like 7 pizza rolls, and you're like, who eats 7 pizza rolls? That's hardly a serving. Like if you line them up, it doesn't even make a slice of pizza. I guess if you unfold them, because they are like rolled over, so I guess you get like double the amount of crust, like single size. So anyway, so pizza rolls per bag is 42. Now I need to know how many bags I need to buy, right? Well, to do that, I need to know how many pizza rolls I expect everyone to eat. So I have like total pizza rolls is going to be my people attending the party multiplied by the average number of pizza rolls eaten per person. And notice I have to scroll. Now, my font's zoomed in a lot, so if I zoom back out, that white bar, I still haven't crossed it, so I'm probably okay. And if you were using, like on your computer, it's going to be fine. It's not going to yell at you. But I'm going to bring that down a line here. And sometimes, now, if you're going on more than one line, Python will add a backslash character. Because remember, Python really likes its white space. If you have like even a space over here, it will be upset and won't run. And it gets this red line and unexpected indent. It's real particular about it. So if you want to bring something down to another line, like I still can't even really see it very well. Like I still have to back it up a little bit. The backslash is the character for that. That tells Python to keep reading the next line as if we didn't stop, or something like that. Does that make sense? Like we didn't stop the line and go down. Like read it all as one line essentially. So it's total pizza rolls. Okay. Then I'm going to have, I know total pizza rolls divided by pizza rolls per bag will tell me how many bags I need to buy, but then I need to round up, right? If I don't get an even number, I can't go to the store and say, hey, store, I want 3.5 bags of pizza rolls. They're going to look at me funny. Like, if you can even find anyone to talk to at Meijer or Kroger anyway. Like, there's no one to talk to anymore. So we'll say this is bags of pizza rolls needed. Then will be my total pizza rolls divided by the pizza rolls per bag, right? Now we've got a couple ways of dealing with this, right? We can look at this number. The easiest way is to round it up, right? That's the easiest way. Like to do a modulus and to check if modulus is 0, we haven't really learned how to do any of that stuff yet. And that's okay. We'll learn about how we can do those sorts of things later. So the easy way then is to just go around. So if we just go Google Python roundup, this is our easiest bet here. And how do you round up a number? The ceil function. Here's our Python ceiling. We skipped a couple, but ceil. So math.ceil will round a number up. Sure. So part of one of the really cool things about Python is it has a really large standard library of bunches of things that come with Python. So if you want to round up, then I'll take my bags of pizza rolls needed, and I'll say, I'm going to change the value of it. Let's reassign the value to math.ceil, and math.ceil then will round up bags of pizza rolls needed. So we're going to get the value, and then we're going to round it up. Now you could do this all on one line if you wanted to. There's no need to keep it here, but I want to show you here in a second how we can use our debugger and see what's happening. So then we'll round it up here, and then we can print out, you need to buy, and then you can just comma separate bags of pizza rolls needed, bags of pizza rolls for the party. And again, I'm just going to try and drop that down a little bit. Now, this one didn't add the backslash. Sometimes it doesn't add it automatically, and PyCharm's really good at knowing why, and I am not. Like, you can add it in yourself, and then it tells you, oh, hey, it's unnecessary. Probably because there's a parenthesis here, it's going to keep on reading until it finds the closing parenthesis. It's pretty smart. So it never hurts to add them in, but like then it yells at you with those yellow lines, and then I get sad. Let's see if this works. So I'm just going to run it real quick, and it tells me I need to buy 4 bags of pizza rolls for the party. Okay? Now, I can sanity check that myself real quick, right? So if I do 4 times 42, that's 168, right? And then 13 times 12, well, 12 times 12 is 144, plus another 1, right? So 156. Yeah, that checks out, right? As a quick little sanity check. All right, but now I want to show you the next really cool thing we can do with an integrated development environment. And why this is so cool is you can do something called a breakpoint. You can make it pause mid-run and actually inspect and see what's happening while it's running. So you can see I've got all these line numbers here on the left, and then there's like a big old gap here. The big old gap is for breakpoints. And a breakpoint tells Python or tells your development environment, hey, stop here, pause. Not actually break. It's kind of a misnomer, but that's okay. So I'm going to do, like here at line 22, I'm going to come and just click in that gray space, and it puts a big fat red dot. That's a breakpoint. Okay? So when it gets to this point here, it will pause running and wait for me to tell it what to do next, which is super cool. So now, instead of right-click run, I'm going to right-click debug. If you right-click run, it's just going to ignore it, because run will just run it. Debug will look for these breakpoints for you and then pause. So right-click and debug, we'll actually be able to see the value of all of our variables as we go. Now, it doesn't zoom well. I apologize. I've not figured out a good way to make this one zoom without using like the zoom tool, which always drives me crazy. But we can see I've got a bunch of variables here with values. If you can't see them, don't worry too much about what it's actually showing there. But you can see it's paused here at line 22, and these are the values of all of these. So I don't have a value for total pizza rolls yet because line 22 hasn't run. So it got to line 22 and paused. Then I've got a couple commands. So there's a couple arrows in the toolbar here now. Most of the time we're going to use this very first one that like kind of goes up and down. That's the step over. So step over says, okay, do that line. Step over that line. Go to the next step. So when I step over, now I'll see total pizza rolls is 156. Again, if you can't see the number up front, don't worry too much about it. But I've got 156 here. Okay, I'm going to step again. So now the next line to run here is line 25. So it hit the breakpoint, and now we're running it line by line by line as I tell it to. So I can say, okay, well, bags of pizza rolls needed turned out to be 3.71428857. We don't care, right? Sure, beyond that doesn't matter. So 3.7-ish bags of pizza rolls needed. Now we get to line 26, where we're going to round it up with this math.ceil, right? So I step over that, and now bags of pizza rolls is now 4, right? And then we'll print our command. Now, the weird thing is, PyCharm uses two different tabs. We don't see any of our output. So all of the output, right now we're in the debugger tab here, all of the output is in the console tab over here. So that I can step and have it actually output the results here. And you'll see, okay, we need 4 bags of pizza rolls for the party. So if something's not calculating right, you can put a breakpoint in and see the values as it's running to see what's happening. So, and that's one reason I kind of like having this on 2 separate lines. It's perfectly legitimate to say, hey, math.ceil up here of an equation. So I can say, hey, do this equation, whatever the results of that are, right? Because we're doing our order of operations, the parentheses happen first. So we'll get this divided by this, then it all gets handed to math.ceil. It's short for ceiling, by the way. I don't know if I mentioned that. The ceiling, like ceiling will round up, floor will round down. Round will actually round like we'd expect it to round, right? Where 0.5 goes up, 0.4999999 is down. So there's all sorts of cool math plans. If you do math dot, you can see all sorts of fun things like arc cosine, cosine, factorial, floor was the rounding down. I don't even know what FR exponent is. I'd have to go look a lot of these up. But like there's a big library of cool things you can do. You can do logs of any base, logs of 10, logs of 2. You can get the standard value of tau, whatever that happens to be. I used to know that, I think, at one point. But a bunch of cool things you can do with the math library built in, right, which is really cool. So that's one of the cool things about Python. There's all sorts of built-in libraries. Yeah?
So when I ran it, it didn't work, and it said that you made math not fine. Does that mean I don't have the math library?
So when I entered it, it actually added a line for me. So PyCharm does a lot of very helpful things. If you want to use a library in Python, you need to use this line that says import. So it added that automatically. I didn't have to type it, which is so if yours might not have added it automatically. So this at the top here says, okay, let me go import a particular module, and a module is a bunch of commands in Python.
As soon as I typed that,
Sweet. Yeah, so it adds the math library for you. And what's actually really cool, you can go and see the math library if you want. When you install Python, all of the Python libraries are installed on your computer as well. So if I go find my Python install, I think mine was C, program files, Python. Nope, Python? Oh no, I got rid of that Python. Mine's in, shoot, where is it? Let me go to my settings here. It is in, yeah, oh, C Python. That's right. Okay, not even program files. So I've got C Python. This is 3.7, but it won't matter here. So there's a libs directory. I'm sorry, not lib. The lib directory is all of the things in Python that came with it, the base install. There's all sorts of ones in here. But if you go find, is it not math? Maybe it's in another one of these. There's like a bunch of folders of things in here too. But you can find all sorts of cool other libraries that will do things, and then you can look at the code for it. So where's one that's interesting? It's random. So the random library will let you generate random values. You can open it up and actually see how the developers of Python wrote their code to do these, let me generate some random values sorts of things. Oh shoot, that doesn't actually work. Mine, it won't actually open file. Let me try it in code. Maybe that'll open up the file. Maybe. If not, I can always use Notepad. Nope, don't want the entitled one. This computer needs to be replaced. Let's try with Notepad. It's your lowest common denominator for text files. Okay, it's real ugly looking, but this is the Python library for random. You do all sorts of cool stuff with random in here. One of the things is next int. We'll talk about that later. Really? Next. That is next int. Okay, just random. Oh, randint. Randint. Okay, that's the one. Randint will give you a random integer in range of A to B, including both endpoints, which is really weird. Most other languages don't include the endpoint. Randint does, and it always trips me up here. But you can generate random numbers. This one does rand range here of a to b plus 1. So if we look up rand range, let's find that one in here somewhere. Oh, here's rand range. It will choose a random item from the range of start to stop, and optionally you can give it a step. We'll talk about that later. Don't worry too much about it. But you can see this is Python code. It's not going to mean a whole lot to us because we haven't done a whole lot of Python yet, but this is literally how it generates random numbers. It's kind of fun. Well, we had the math. I don't remember where the math file is. It's somewhere, but we could go find it if we care to, and you can look up all the math stuff if you wanted. Oh,
you could from step 1 itself and just put a breakpoint and we would let's say like a line to that.
You just put the breakpoint at line 1.
Okay.
Yep. Yeah. If you wanted to break and watch from the beginning, you just put it at the first line. So if I try and put a breakpoint at import math, it won't actually do anything. Actually, maybe it will. I don't remember. Generally, it waits till like your first command that you're actually asking it to do something. So that's a breakpoint, so you can actually see what's happening behind the scenes, which is really fun. So again, I'd like breaking these things up into multiple lines so that you can see what the values are each step of the way, rather than doing it all at once, right? I mean, we could have put all of these calculations on a single line here, right? Because we have all these values and we could do all these sorts of things. You'll notice I gave all of them names though. Generally in programming, it's considered bad form to just use a number with no name attached. It's known as a magic number because there's no name associated with it. So you have to like know in your head what that number means. It's kind of like magic. So if I just said, okay, divided by 42 was like over here, perfectly legitimate math here. That's okay. But what am I going to remember what 42 means later, the next time I go look at my program? So a better practice is to always give your values variable names. And then we use the variable name when we're doing the arithmetic so that as I'm reading my code, I can say, okay, your bags of pizza rolls needed is going to be equal to total pizza rolls divided by pizza rolls per bag. Like that, you can just kind of read, and 99% of people will understand what you're doing.
And so you change only one page, not all the first page.
Yep, and then because inflation is going to mean that I'm going to give you less pizza rolls per bag to keep the same price point. Because if you're paying $2.99 per bag of Tostino's pizza rolls, because you're used to paying $2.99 per bag, and I now give you 38 pizza rolls instead of 42, oh, no one's the wiser, except the people who actually look at these numbers and economists and things. So all sorts of our foods now are decreasing in size slowly to keep the same price points, because if the price goes up, people tend to get upset about it because we're very emotional people, which is weirdly true. Like for the longest time, economics thought it was very mathematical. Like, hey, as the price increases, people buy it less. And they're like, fixed formula, perfect, easy. Turns out it doesn't work like that. Not exactly. So behavioral economics that takes into account human behavior is the new hot thing in economics, and probably not the most recent, but a couple of years ago, a guy, I forget his name now, got the Nobel Prize for economics for studying behavioral economics and trying to understand why does this math formula not work out? Well, turns out people are not actually great at math, and we're driven more by emotion than math. So not everyone carries a calculator around in their pocket and like says, hey, what's the price per unit when I'm buying these things?
How much spaghetti?
For spaghetti?
How much spaghetti is the name of the Nobel Prize?
Oh, I don't remember. I'd have to Google his name. I don't know. What's Nobel Prize in economics, behavioral economics. I don't know, or econ or something. I can't even spell right. Let's see. 5 notable Nobel Prizes in the study of behavioral economics. Herbert Simon, Gary Becker, Daniel Kahneman, Amos Tversky, Robert Schiller, and Richard Thaler. Richard Thaler is the one I'm thinking of. Is the most recent that I've got in my head. That rings the most bell. Predictable irrationality that defy economic theory. His nudge theory. But this is actually a really good read if you're into that sort of thing at all. For the longest time, I thought it's okay if I don't understand people. It doesn't matter at all. Like, I'm good at computers. I can just do computer things. Doesn't really work like that because computer things are used by people. Who knew? So understanding behavior is helpful for designing programs that are useful for people and that sort of thing. Again, there's all sorts of interesting fields of study. And there's only so much time in the day, but really interesting if you want to get into that sort of thing. Oh, and it's after 7 now. I think we're due for a break. You okay with that if we take 10? If you need one earlier, just shout at me, please. Like, I'm really okay with that. Literally, it's your class. I've got things I want to cover. I don't care if we take 10 breaks. I don't care if we take 1 break. Generally, I'll try and break every hour because like I still need a break and I need to go drink stuff. But it's totally up to you folks. All right, so why don't we take 10? We'll come back at 7:13 or so. Put some more music on. 7:13. And we'll be back in a minute. All right, we got 7:13. I think we're ready to bring it on back. Got a couple more things, not too much more, and then we're going to do another lab. Again, ideally you get it done before you walk out the door. If you're tired and done with it, that's okay. You've got all week to work on it. Just get it in before the next class starts. And we should be in pretty good shape there. And then we'll also talk about the first project. So the labs are like small little practices. The project is going to be this first one, not all that bigger because like we haven't really done a whole lot yet. But generally with the labs, like I'll sit with you and help you get it done. The projects, I'll point you in the right direction if you're stuck somewhere, but I won't give it to you. With the labs, like if you're stuck somewhere, I'll help you write the code. So that's generally the distinction with those. Which I did unmuted, right? Yeah, I did unmute. Good. Okay. So a couple other fun things. So we did operators, we did order of precedence. Working with strings is really interesting here. So if I were to have a string for, what do I want to call this? Like, I don't know. How about we'll say name is Nana. So my kids call their grandmother Nana. The first kid couldn't pronounce grandma, and the first thing that came out was like Nana was as close as she could get, so they stuck with Nana because they were the first grandkids, so they got to name her. So she's Nana. So if we print Nana, we get, I'm sorry, name, print Nana, we don't get anything. This is name Nana is not defined. We don't have a variable named Nana. But if we print name, right, we say, hey, Python, go get the value stored at name. It'll print Nana. Now, Python lets you do some fun stuff here. So I can print name times 3, and then right, you can comma separate things, and I'll say Batman. And we'll get Nana, 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 Batman. So a string times a number works, which is really weird. You wouldn't expect it to, but Python says, okay, you want a string repeated 3 times? I'll give you that string repeated 3 times. Why not? So it's not going to yell at you, right? Other languages don't let you do this, but Python says, oh, sure, go for it. Why not? And again, we've been comma separating things. Another fun distinction here, if you were to say print 1,000,000 here, you don't get 1,000,000 back out. So commas are actually not allowed in numbers. So that's the same thing as telling Python print 1, comma, 000, comma, 000, and 000 is still 0. Right? We can comma separate things, and Python will just print them separated with spaces. So if you want 1,000,000, what you would do is, actually, let me do that over here. We're going to save the code here. So if we're to print 1,000,000, or print 1, comma, right? All of those are bad outputs. We have inconsistent spacing, I'm sorry. Right? And it's even yelling at us that usually after a comma, there's a space. So like that's kind of your hint that it was wrong here. If you actually wanted 1,000,000, you can use the underscore character for a digit separator. With the underscore character, it knows, hey, you're still a numeric value. Because underscore is not a numeric value, but you can use that for digit groupings. The other dumb thing you can do, though, is you can put them anywhere you want. So you can have like that, which is super weird. Don't do this, right? But Python doesn't care. This is legal, but wrong, right? This is right and helpful. This is wrong, but pretty. And this is wrong and ugly, right? Not having spaces around your commas is wrong and ugly, right? This is wrong, but prettier. This is right and helpful, and this is legal but wrong. So we should get out our results here then. Oh, I have too many. Sorry, this would be there. That's the correct number. So this is still 6 zeros. This is still 6 zeros here. Sorry, I had too many before. Let me run that one more time. Now we still get out 1,000,000. Now notice it doesn't print the separators though. There's no digit groupings here when we print. There's ways to do that in Python. I don't think we need to tackle that tonight. It's not too hard to do, but you just have to go Google it. So you'd say Python print format, or what is it, integer format digit groupings or something. And you'll probably get close enough, yeah. Digit groupings, not in hexadecimal. No, we don't want that. Digit separators for Python integers. No, that's... Nope. All right, that was not helpful. Nope. Number format exam. Okay, this one will probably be helpful. Number formatting is what we're doing here. So if you're printing something, you're formatting it. You can do these sorts of things here, which is really funny looking. So we'll get to some of this stuff later. It exists. You'll Google and go down a rabbit hole, and then you'll be confused, but it will do the right thing. And you're like, well, why does it do the right thing? So don't worry too much about it here. But you can if you want to. You can make it print out real nice and pretty. Okay. Oh, I did that in the wrong spot. I wanted to do that at the end. I'm sorry. Let's go back here. Yeah, I'll throw that at the end. Sure. Now is it happy? Okay, now it's a little happier. So you can do strings and multiplication. You can take a string plus a string. So if I were to say print, I'm sorry, let's say we had name was Nana. Right? Oh no, we didn't even do that in here, did we? So let's do name as Nana, and then we'll print Nana times 3 plus, no, comma, sorry. Batman. Name, yes, thank you, name. Name times 3, Batman. We'll get Nana, 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 Batman. Right, because you can do that. Sure. Other things you can do with strings. So if we also have then, how about last name, maybe? Well, we make last name be Batman. We can do that. We can print name plus last name. So the plus operator, generally you would think only works with string, with integers or floating point numbers. You can take a string, and it's not add. The technical term for that is concatenation, where it just sticks them together. So a string plus a string will just attach them with no spaces. So this is a string concatenation, attaches with no spaces. So if I wanted a space between Nana and Batman, I would need to add a space myself, right? We get Nana Batman, all one word here. Sorry, I can pull it up a little bit again. It doesn't, no, it can't even pull up that high because it's down low. That's annoying, I'm sorry. It kind of hides. So if you wanted to add your own space then, you could add in a space string and say, okay, take a string variable, add a space, take another string variable, and add it. Well, we would get the exact same result by just comma separating with print, because printing with comma separation here will automatically add a space between the things you comma separate. Now, sometimes that's not what you want, though, right? If you wanted to say like a percentage of some number here, so we'll say, I don't know, we have students enrolled, I think was 24, and then students attending in person is, I don't know, we'll just say 16. I didn't actually count, but I'm just going to guess here. Students, there we go. Students attending in person. If I wanted to print a percentage here, right? So I'd say my students attending in person divided by this, comma, percent sign. Well, actually, I want that times 100, right? Because I want it as a percentage here. Percent of students attend in person. And I'll just bump that down a line so it's a little bit nicer looking. My percent sign's not going to touch because when you comma separate, it automatically adds a space. So now the formatting looks a little bit dumb. So in that case, it might be nice then, instead of comma separating, to then add that together so that it touches. Oh, but now it errors. It says unsupported operand types for plus, float, and string. I can't take a float and take a string and add them together. A string and a string you can do, right? Because it will say, oh, you don't actually mean add, you mean concatenate. Or an int and an int, or a float and a float. Yes, you can add together arithmetically? Numerically? Sure, there's a word for it. So it gets confused here. So the trick for that then is you need to tell Python you want this as a string. So to tell Python you want something as a string, you say str for string, and then you put it in parentheses. So str will convert to a string. So anything that's inside the parentheses will get turned into a string. Yes, sir?
Can you explain the difference between a float and string?
So floats are the numbers with decimal places. So if I'm taking a number divided by another number, I'm going to get a floating point result. Even if it's like 4 divided by 2, I'll still get 2.0. It'll be a float. I'm sorry? There is. So Python is pretty good about that sort of thing, and it has a very large maximum, but what even is it? Python largest float is, let's see what it is. 1.79 e to the 308. So like 308 decimal places is about as big as you can get. If you need more than 308 decimal places, I don't want to know what you're doing, right? Like, seriously, NASA had a really cool article, the Jet Propulsion Lab, about how many digits of pi we need to be able to get someone to Mars, and it's like 7. That blew my mind. Like, it was crazy. So what is it? Digits of pi needed to get to Mars, or something like that. There's a whole cool article they put out about it. Yeah, the Jet Propulsion Lab at NASA says, how many digits of pi do we really need? Because as you know, pi is infinite and really, really, really long. All right, so for Voyager 1 going 12.5 billion miles away, they needed pi to 15 digits for Voyager 1 to be accurate. What do they say? So a 25 billion mile diameter circle would only be off by 1.5 inches with 15 decimal places to get within landing where it needs to go with 15 decimal places. If you need 308, I got nothing for you. You might need it for some crazy astrophysics somewhere. I don't know. That's honestly beyond me. So, right. So how many do they actually say then they need? 39 or 40 decimal places to get within, to calculate the circumference of a circle with a radius of 46 billion light years to an accuracy equal to the diameter of a hydrogen atom. I can't even comprehend those numbers. Like, they're saying that the entire universe diameter down to the accuracy of a hydrogen atom size with 40 decimal places. That stuff hurts my head. Like, legitimately, I got nothing. So, okay, we don't need that many, but you can get very precise if you want. Very precise if you want. So if I want to take a string or take something that is a numeric value and turn it into a string, I will convert it with str, which is short for string. Str, yes, sir.
Before we added that, the problem would be trying to add an integer plus
a float and a string.
Those are 24 times 16. They don't move.
Well, so when you divide, you're going to get a floating result. Yep. Yeah, the division. Even with an integer, you can't add an int and a string. It won't let you do it. So even if we didn't have that division there, the two types won't match. You can multiply a string by a number, and you'll just get that many repeated over and over and over, but you can't do addition. So we can convert to a string if we want. Then we can get that as a single output here. And now our percent sign touches, and we're like, oh, look, we're so good at this. Now my formatting is ever so slightly prettier for all this extra work. But you can, sure, that's okay. You all right so far? So we can do fun things with those sorts of values. Okay, where'd we go here?
We don't use the word function in the JavaScript, so we haven't mentioned anything.
No, we haven't talked about those yet. It is one, but yeah, it's a function, but it's a meaningless word at this point for you guys. Yeah.
Are you going to save this?
Yeah, anything here in PyCharm I'm going to save with GitHub and put on the Git repository.
So we can access
Yep. Yeah, I can commit here now. So here's after first break. Right, commits are free, essentially free. There's like small electrical usage for every time we commit because the cloud has to do some work, but essentially free. So now if I view on GitHub, right, this will launch my repository, and this one's linked out in D2L in the course info section. You go to the repository here if you want. Course repository will take you to my Git repository for the class, and then each week I'll make a different folder. You can go to week 2 and look at the main py file and take a look at all this stuff. Yep, so it'll all be out there for you. Yep, and if you want more comments like this, please just shout. We're a little bad in the industry in general in that we like to imagine in a rainbows and unicorn kind of world that everything will be perfect, and my code is so pretty and so well named that you don't need comments to know what it's doing. I admit that's a little bit pie in the sky dream, But generally, that's what we try and do in the industry. When we write code, we like to minimize the number of comments we need because you should know what it's doing by the code. Like when you see students attending in person divided by students enrolled times 100, you'll probably know what that means. And now I don't even really feel too bad about having 100 here because that's not necessarily a magic number. I mean, I guess it is, but like, what would I call it? Like value to multiply to get a whole percentage or something silly. Like at that point, I don't feel too bad about 100, but I don't want to just have some like 38 for pizza rolls per bag and don't put a 38 in here because you won't know what 38 means, right? So again, there's a bit of an art to it. There's not a hard and fast rule that this is the right way only to do it, right? And that's what I really like about coding. It's a very creative process that you're going to solve problems. The hard part of coding is solving the problem in a way that you can make the computer do it, right? I give you a big problem. You need to figure out these small steps, step by step by step by step by step by step, that then you can translate into Python code. It's going to feel like the translating to Python code is the hard part, but I promise you that part will get easier. The problem solving never gets easier, right? You're always solving problems and having to figure out, okay, here's what I need to have accomplished. How do I make a stupid computer do it? Because you have to break it down step by step by step. There's a really funny video. I can't play YouTube videos without getting copyright strikes though, where they like ask a kid to write directions for making a peanut butter and jelly sandwich. And then you follow the directions as literally as possible. So if they say put the peanut butter on the bread, you take the jar of peanut butter and put it on top of the bread. You don't take it out and scoop it because they didn't tell you to scoop it. Like this sort of thing. So you can do all sorts of fun things like with literally interpreting directions. And like when you follow a recipe, you have to be pretty explicit to what it is. And there's that funny video if you watch, what's that show? Oh, Schitt's Creek, where they say fold in the cheese. And it was a whole meme for a while. No? Okay, that's all right. It was funny. The recipe says fold in the cheese, and they've never cooked before because they're a former rich family who got in trouble with the IRS or something. And they're like, I don't know how to fold in the cheese. What does it mean, fold in the cheese? It's funnier if you watch it, sorry. But that's sort of like you need to be explicit in your direction. So it's problem solving. That's what makes it interesting when you write code. All right, so now the only thing we've done in our programs is we've had the exact same result every single time, which is not very useful. Slightly useful, right? Like for my particular party, I now know how many bags of pizza rolls to buy. But if I wanted to make a helpful program that said, hey, let anybody figure out how many bags of pizza rolls they need to buy for their party, this program can't do it unless we're going to say, oh, just go change a couple numbers here, which with Python, they're probably going to be successful. You know, change 3 numbers here and you're good to go and hit run. You can probably tell most people how to do it. But what would be nicer here is if the program asked them when they just ran it. We can say, hey, here's some code, just hit the run button and then answer the questions, right? If we can get input from the user. So we call these things variables here. These are our variables where we're storing information. The reason why they're called variables is because the value can vary, right? Right now, it will only ever be 13. But what I can do is I can say, instead of it being 13, I want to change it to be variable based on the user entering a value. So I'll ask the user, hey, tell me how many people are coming to the party. And when they run the program, then they can type in how many people are coming to the party. So we can do that. So we can say, hey, I want this as an input. We'll say how many people are coming to the party. Now, the problem is inputs are only ever done with strings. So when I type some answer in, Python will only treat it as a string because it's a bunch of text. It doesn't know that I'm asking for a number. So if you want to turn it into a number, we need to convert it here. We'll say, hey, I want this to be an int of whatever we get back here. So int of the result of input says, whatever the user types in, turn it into an integer, please, and then save that in my people attending the party variable. So we're asking the user, enter a value, then converting to an int. And most of the time, they're going to answer a whole number. They won't say, I'm going to have 12 and a half people come to the party, because I don't know how that even works. Now, users will do all sorts of weird things, and we have no control over what users do. Right now, we're just going to let our program crash, and we're going to feel bad about it. And that's okay, right? We haven't figured out how to make it not crash yet. This is only week 2. We'll get there. But when you're using a program or like an app on your phone and it crashes, for some reason, that like automatically elevates your blood pressure and gets you upset. You're like, oh, this stupid thing crashed on me again. So crashing programs is bad form. right? And then users won't want to use our program, and then we're not going to sell our apps or whatever we happen to make, or they're not going to want to go to our website or use our tool, or if they have to use it because it's like a homegrown tool that a company uses, they're going to think their IT department's stupid. Like, why can't IT fix this? It should be so easy. Yeah, okay. So it'll crash and we'll feel bad, but that's okay. So now it will be a variable by whatever the user types in. So when I run this here, the program just sits and waits. It looks like it's doing nothing, but it's waiting for me to type something in at the console. So we're only going to get to console-based applications. I apologize. We won't get to graphical user interfaces where like there's actually buttons to click on because we have so much other stuff to do. There are ways to write graphical programs in Python, and it's not hard. We just don't have time for it because we only have 14 weeks. So most people don't run most end users won't use programs that like ask them to type something in at the console like this, and they'll be confused. And that's okay. We'll get to graphical programs, or you can get to graphical programs later. All the same concepts apply. There's a couple extra bells and whistles. So it just sits and waits for them to type the answer in. The program is still running. Python is still running. So if I look at Task Manager, I still have Python running here somewhere. We sort by name and find Python. Seriously, Task Manager? So the Python executable is running, right? Python is currently running my program, actively running it. It's just sitting and waiting. It's not doing anything. It's just waiting for me to type something in. So once I type a value in, so if I type 10, T-E-N, and give it text, it's going to crash. Invalid literal for int with base 10, quote, 10. Python's a little bit dumb. You can't give it the spelling of a word, and that's okay. Most people won't spell their numbers anyway, but if a user does, it will just crash. Or if they say 10 people are coming, it will crash and say, I don't know what 10 people are coming is as an integer of base 10. Again, it's okay so far. So if you get these weird errors because we typed something in that was unexpected, that's okay. I'm sorry, yeah.
There is n.
You could,
Just do it.
no, because the input will only ever come back as a string. You have to convert first. So there's ways to try and convert and not crash that we'll get to later. Yep. All right, but if I'm a nice user and I enter 10 in numeric value, now the rest will run and we'll say, okay, I need 4 bags of pizza rolls. Because it was able to correctly do this arithmetic. And again, this is when debugging is fun. I can put a breakpoint here and I can run it with debug mode and I can actually see the value of it. Oh, I stopped here. So if you wanted to run without having to like next, run to the next breakpoint, you can just hit continue. That's kind of a little play button here. We'll go to the next breakpoint. Or you can run it line by line by line by line. So I'm going to step over, and it's going to look like debugging stopped. Sorry, it's a little small, but it's just waiting at the console for me to type something in. So if I type in 120 people are coming to my party, and I go back to the debugger tab, now I can see people attending the party is 120, right? Now it's a real party, right? I don't know, what time, like, there's a gathering and there's a party, or at some number of people, it turns into a party. But I already start with 8, so it's hard to say 8 people makes a party. Where like most people, you say if you're going out with 8 friends, it's a party already. So I think that kind of thing is fun. Anyway, so our number of pizza rolls we would need then is going to be 38 bags of pizza rolls. All right. We probably don't have 38 bags of pizza rolls available at Meyer because of our supply chain issues. Good luck. You might need a couple trips or plan ahead. Okay. And if you want to stop debugging, you can either continue it again and let it finish, or you can just hit the stop button here and it will just hard stop, terminate, game over. Like it quits Python essentially. And you can do that if you want. And then you'll get this process finished with exit code 1. Anything that's not 0 means it stopped not expectedly, essentially. So 1 means we killed it. It's done, game over. Usually it says process exit with exit code 0 because it successfully finished.
I can exit the debug while continuously running it. I mean, I don't want to exit the debug. Just go ahead with the program.
You would just do the continue button or resume would finish it out.
Okay.
Yep. Or go to the next breakpoint. Hey, thanks for following along in chat, folks. I got to remember to keep a look here. I'm sorry. If you follow along, you get points for watching. It's a Twitch thing, and you can redeem them for funny things. I have a deck of dad joke cards and a deck of knock knock joke cards because sometimes you just need a break. because it's just been too long. So I'm happy to redeem those if you folks just want a dad joke or a knock knock joke for nonsense, because like it's a long class. It really is. All right, and because I mentioned it, someone wanted the knock knock joke. So we'll do one real quick. All right, let me grab that. I got these as a Christmas gift from my mother-in-law, because she knows I like knock knock jokes and dad jokes. I used to collect them on my phone, and I still have a collection of them here, but they're like official packs now. Some of the knock knock jokes are terrible, which I think is the point, and some are like halfway decent. I don't even get that one. I think this one's probably terrible too. Oh, okay, I get it now. I'm a little slow. Knock knock. Cook. Yes, you are. Okay. Okay, sure. Knock knock. Wire. Why are you asking me? Okay. I mean, sure. So I've got those. It's a long class, especially being 4 hours at night. So again, hopefully I won't go past 8:30 most nights, and then we'll switch over to lab time and get your lab done and get out the door. That's mostly the goal for you here. Just peeking at the schedule here. The days projects are due, again, they're due before class starts, because the first thing I'll do in class, so like come June 6th, looking at June already, holy cow, I'll go over the solution to project 1, and I'll show you how I might solve that problem. Most of the time people think it's really useful. I've had like 2 people in the last 10 years say they thought that was a big waste of time, me answering the problems. So most people say it's useful, and until the majority of people say it's a waste of their time, I'll keep doing it, because again, there's so many different ways you can solve problems, right? Not everyone will solve it the same way. So my approach might be different, and it likely will be different because honestly, I've been doing it for 15 years, right? So I might think of a couple things differently here. If your program works, you'll get points, right? The points that I'll give you for projects, and we'll talk about the project 1 rubric, are literally, if it does this piece, you get the points. If it does this piece, you get the points. So regardless of if it does it quickly or slowly, or if it's pretty or if it's ugly, that's okay. If it gets the job done, you'll get the points, right? It takes time and practice to get better at coding, because it really is an art. Just like anything else, you have to practice more and more and more. So I'm not expecting you to write the most efficient, the cleanest, the simplest code to start. That's okay. One project I felt terrible because somebody had like 3,000 lines of code that I did in like 50. It's okay. I felt bad because they spent so much time on it, but a lot of it was copy paste. Like here, I wrote 50 lines, I copied it and did it 10 different times, changed a couple things. But there's shortcuts and different ways to go about it. So I'll show my solutions in class. So we'll have a little bit of time to do that, and then we'll talk about the new stuff. We'll do the lab and any individual project stuff that we have going on. Yeah, and when it comes to labs, you folks are welcome to work together. Generally, pairs is ideal, but if you need like a trio, 4 people, there's just not enough work for 4 people to do it. And then most of the time, it's like 3 people stand around and watch one person solve it, and then the 3 people go back and write it themselves. So pairs is ideal, but if you got a trio up, that's okay too. We'll go from there. So that's for labs though. The labs are for your practice. They're meant to be low stakes. Before you get it done, before you walk out the door, or like before the next week starts. But just your chance to practice the stuff we've talked about. The projects are individual efforts only, right? And someone had asked, they found there was a cool little conversion in a different class of mine that they went online to look up. They said, do I need to cite this? I said, yeah. If it didn't come from the book, or if I didn't show it to you, I'd expect you to cite it. So you Googled it, hey, we found this, I don't know, whatever maximum is here, just copy it in and say, got it here, like that. And that's enough for a citation, right? You found a function, you found whatever it happened to be here. This is how I rounded my numbers and added in comma separators or something. Sure, well, we're okay, right? Just like an English paper. If you use someone else's idea, someone else's work, you cite your source. What you're not doing is taking someone else's paper and turning it as one giant citation, right? And ideally, that's sort of why I get paid to do this sort of thing, is I'm going to try and give you projects that you won't go out and be able to Google a solution for. Occasionally, there's some that I just really like, but the ones you'll find solutions for online are obviously different and like more advanced than what our level would be. So usually I can tell if people copy paste that sort of thing. But again, internet's fair game, okay? You'll probably end up down a rabbit hole though, because everything you need we should have done in class and had out of the textbook, right? The Stack Overflow goes nuts, and you'll see like when I'm Googling stuff, I'm skipping 2 or 3 different links already to try and find one that I think looks correct or what I might need. So you're probably going to spend more time trying to Google it anyway, rather than, okay, oh, it's about strings and conversions. Let me just go look it up in the textbook here. So I apologize if I keep looking at you individually. I like looking around the room and finding people, and some of you are just like right in the middle, and I don't go left and right as often. So apologies if I keep looking right at you. All right, so let's see. So I think we're good to keep moving here. So some inputs then. Now, the next thing we can do is say, well, how many pizza rolls do people eat on average? Because if you're inviting a bunch of kids over, it's probably less than a bunch of teenagers, which is probably more than a bunch of adults. Right? Most adults won't eat like 24 pizza rolls, but if you invite teenagers over, I'm out of pizza rolls like that. Right? My son and his friends, they're gone. I don't know. So we'll ask. So I'm just pretty much going to copy this line here. Maybe if I can get it to scroll over. Where's my scroll bar? There it is. There we go. So we'll do this, and then we'll say how many pizza rolls does someone, I don't know, or will a guest eat on average? Will a guest eat on average? And now it's possible they're going to tell me 7.5 because they're weird. So instead of converting to an int, I can convert to a float. I can say, hey, let's turn that into a floating point number just in case, because 7.5 is not an integer. It would fail. Okay, so I can bump these down a line if we want to make it look a little prettier here. Still, my font's just a little bit large, just so it fits well. So we'll say, okay, how many pizza rolls will a guest eat on average? We'll take that input, which will be whatever they've typed in as a string, and say, hey, Python, try and turn that into a float, please. They probably gave me a floating point number. Please, hopefully not crash. Right? Now, the pizza rolls per bag is probably fine. Now, we could ask them too, like, hey, are you buying pizza rolls from Costco where you're going to get 100 in a bag, or are you buying pizza rolls from Meijer where you're getting 38 in a bag? Or the family size bag, if we wanted. Sure, right? Why not? We might as well ask them, right? How many pizza rolls come in a bag? Okay, and then we could even be more helpful, right? We could ask for the cost of a bag of pizza rolls. Cost of bag of pizza rolls. And that one's probably, again, a floating point number because we'll probably know it's like 59 cents or 99 cents or whatever. They probably won't round up. So we'll say a float of the input, input here, of, oh goodness, how much does a bag of pizza rolls cost? And then we'll say no $, please. Because if you have the $, it won't be able to convert it to a float. So in my prompt, I'm going to hint at them, please don't give me a $. Right? If the more information you can give a user, the more likely you are to get better input. Right? If you say, how tall are you? You might get number of inches. Probably not, but you might, especially if you're asking an engineer. You might get number of meters if you're asking someone international using a better system. Right? You might get feet and inches. So tell them what you want their input to look like. It's not a guarantee that you'll get it right, but you're more likely to get it right if you ask for a specific type of input here. Okay, so we'll get the cost of the bag here. I'll bump all those down. Okay, so then we'll find out the total pizza rolls, we'll find out the bags of pizza rolls needed, and then we can even tell them then how much it will cost. It will cost, I don't know, we could do our $sign here, and then we could comma separate, and it would add a space, and it would look a little ugly, right? Or we could concatenate a string of the result, the bags of pizza rolls needed times the cost of a bag of pizza rolls, right? So again, totally optional. This is only to make the output look ever so slightly prettier. Here is why I'm doing this instead of comma separating and having to add the string value here. Okay, not too big of a deal. Both ways will work. I'm not going to take points off because you don't have spaces or you do have spaces. I could care less, right? That's just a style preference here. But now we should be able to figure this out. So when I run it now, okay, how many people are coming to our party? Well, let's say we're going to buy pizza rolls for class. There's 16 of us in the class. How many pizza rolls do you think we'll eat on average? I'll eat like 15 if I'm hungry for dinner. I don't know about you folks. More or less? 12? Okay. So our average is like 13 and a half then, right? 12 and 15, all right. So 13 and a half eat pizza rolls on average. And how many pizza rolls come in a bag? I think it was 38 now, thanks to inflation. Right, we're getting a smaller bag here. And that bag costs, what, $3.29 or something? Oh, no dollar sign, right? $3.29 without a dollar sign. So we'll get, okay, we need to buy 6 bags of pizza rolls. It will cost $19.74 and 2 gazillionths of a penny. Python is really bad at precise math because floating point arithmetic is apparently really hard. All languages tend to be bad at this, and I don't know why. Go ask an electrical engineer or a computer engineer. They probably know why. And again, this is why rounding is nice. Like we could round to the nearest penny and we wouldn't see all this ugliness here. I don't care much, right? It's okay. Okay. If you want to fight me for that 2 gazillionth of a pizza roll, I'll just let you have it. We don't even have to arm wrestle. It's okay. I make my kids arm wrestle me for leftovers sometimes because I want the leftovers and they don't win. So is that wrong? My 14-year-old is getting closer, but not close enough. So decimal is a better type for specific decimals, etc. I would just generally round Filler and Benny. Yeah, usually I just use rounding because that little tiny bit doesn't matter much. But now our program is a little bit more interesting because we're dealing with user input, right? And it will be variable. Anytime you run it now, you can pick different numbers and you'll get a different result, but according to the same formula, right? But this way you don't have to go in and change anything. It all is based on user input, which is infinitely more interesting than it always telling me I need to buy 4 bags of pizza rolls every time. Okay? Now again, whether or not you're going to send someone a Python file and tell them, hey, go download Python, go to the command prompt and run python.exe and give it the name of your file here, probably not. We're still not like super friendly usable programs for people. Python's not really made for that. Let's just be honest. You're probably not going to write a Python script and send it to your mom and say, hey mom, run this and it'll tell you how many ingredients you need to buy to make pie for Thanksgiving. My mother uses spreadsheets because she's an engineer and she loves her spreadsheets. She literally has a pie spreadsheet for Thanksgiving. Because like all the different kinds of pie need different amounts of different ingredients and flours and things. And anyway, all right, so you folks are doing pretty well. You're doing all right. Let's see. What else do we have in here? You're asking the user for input, converting input, right? Getting int of different values. The airspeed velocity of an unladen swallow. Dr. Severance is a Monty Python fan. He's a good guy. And then if you can't convert, right, it fails, yada, yada, yada. Comments, we talked about comments. Variable names is important. We talked about that a little earlier. Python could care less if you do this or if you do this, right? Code is not just for Python. It is for the computer, but not only for the computer, right? Code first is for people. Your people, I'm people, your coworkers are people, the people who are going to come after you and maintain your programs are people, right? So let's be kind to people and make our programs nice and pretty. And then debugging here, again, he doesn't use the development environment. All of his examples are coming from idle, so you'll see like that triple prompt, and you'll see sorts of issues. Don't worry too much about that, but the same sort of idea. If you get a name error, you haven't typed the right word. Now, this is why I like IDEs. So if you're trying to calculate principal and interest on a loan here, it's going to tell you you typed the thing wrong before you even run it. So it avoids a lot of these errors here. So if we were to say, what was his example? So with a loan, right? So if we said we need probably an integer. So we'll say, here's the loan amount. It'll be an int of an input. Enter the total loan amount. No dollar sign, please, right? And then we want the interest rate. Interest rate is going to be probably a floating point value of an input. For the interest rate, like 0.06, right, for 6%. Otherwise, we have to, if you give me 6, it's not 600%, then I have to do some arithmetic myself. So I'll just say like 0.06. And then we could calculate that. So then I'll have my, what else do we, I guess we need to know how long the loan is for, right? How many payments, all sorts of other calculations, that's fine. But if we were to say, then my, so a payment would say, if I mistype loan amount, because I mistype things all the time, like loan amount, right? It's going to give me the red line right now saying that's unresolved reference. So before it even errors in Python, my IDE will tell me you've done a bad thing with a red line. Red lines are bad. Now, the fun thing, though, right, is going to be the loan amount times the interest rate, like divided by 12. We'll say it's 12 months. Why not? And then we can print the monthly payment of the payment. And I can run it. And then it hasn't failed yet because Python is an interpreted language. When you tell Python to start running your program here, it starts at the top and works its way down. It hasn't run into an error yet, so it is okay to run this. The top stuff will still work. We can still have our party and have a bunch of pizza rolls, right? Enter the loan amount. We'll say we borrowed $1,000. Interest rate, we'll just do 0.06. Why not? Now it finally fails when it gets to that line. So Python's not compiled. Like other languages like a Java or a C# or a C++, you have to compile it first, and you'll give you a compile error. We get an error while it's running here that it failed. Or the IDE is telling you, hey, dummy, this won't work. And if you forgot or didn't notice it, that's okay. We've got like 60 lines of code here. If you didn't notice the red line, it's not too big of a deal. It does give you this small little hint. On the far right, it gives you these like little coloring bands there. They're kind of hard to see, but there is one that's a bright red band. So just at a glance, you can see in your file, I've got 4 yellow warnings here, and they're telling me what those were. It was for a minute there. It's not now. This one is another. Well, that's a breakpoint. That one's a breakpoint. So like there's a color code for what these kind of things mean here. You can kind of at a glance see that there's a red line here, and it might crash here. Okay. But if you get these name not defined, means you gave it a variable name that you haven't declared before. You haven't told Python you want a thing called a loan amount. Leon amount. I don't even know how to say it. Right, but that's the other great thing is we just start typing, you just tab it along, it's IntelliSense will fill it in for you. Okay, and so this is going to be, now the loan amount times the interest rate divided by 12 is just the interest. So this is the interest only monthly payment, right? Interest only monthly payment. This isn't paying down the principal balance. This is only paying the interest on your loan. And then in a year, you have to pay the whole balance back or whatever our thing happened to be here. You can do all sorts of fun stuff with these.
You already answered this question, but this one is saved because it's in the memory now.
When it runs, it will automatically save. Yeah, so every time you run your file, it will save the Python file because Python will actually go read it off of the disk when we execute Python here. Yeah, so just running it will save it. So as you like, if I make some changes here, I think it tells me if it's been saved or not. There's some way to show it's been saved or not. I forget where it is. Maybe not. I thought it gave you like a visual clue here. So in Java, it compiles everything, even if there's been an error before the end of the code. So it'll fail to compile. So in a compiled language, if you have an error like this, it's a compile time error, and it won't even compile. You won't get any code to run. Right? Python will just start at the top and read to the bottom, and if it runs into an error, then it fails, which is sort of nice and also kind of weird. So it depends on where your error is. It might just crash in the middle. Okay, so I think we're good with that one there. And that got us most of the way through chapter 2. Okay, awesome. So let's talk about a lab exercise and then the project. That sound like a good plan? All right, so let me go make a link here for you to get a new repository for lab 1. Didn't I? 2131? Did I not? I'm super confused. We did this, right? Did I name it wrong? I named it wrong, didn't I? What do I have for summer? It's not. I did. I put it in the wrong class. Okay. Thank you. All right. I did the wrong thing. Let's try this. Yes. Click. Come on. You need to be more patient. It's loading. Let's take a deep breath. There it goes. All right, so here's CIS 2131. Sorry, okay, so the last one, you probably never saw it was in the wrong classroom, but it's going to bother me that it wasn't organized right. So this is summer 2022. So this will be our own distinct classroom here. We don't need to do any of that, which is nice. There we go, make an assignment. So CIS 2131, summer 2022. This is lab 1. Then, and we want my Python template. And we don't need any tests or feedback. All right. Okay, so we got our link. From here to assignments. We'll do lab 1. This will be our salary calculator. Labs. They'll do next week before class starts at 6 p.m. Submit the URL to your main.py file. And you're submitting labs text. Okay. So write a Python program that asks the user for their hourly wage and numbers of hours worked this week. Print their weekly salary before taxes, then calculate 10% tax. This is just a gross estimate. I apologize. We're not writing good tax software, so we're just going to pretend everyone pays 10% taxes. I know that's not true. So we'll just work with me, okay? That's the taxes and print total taxes owed and net salary. We're going to print 3 things, right? We're going to print their salary before taxes, which is just a straight wages times hours worked, right? $7.25 an hour times 40 hours a week, minimum wage, you make crap, right? Then we'll take 10% taxes, calculate 10% of that as taxes, print the total taxes owed, and their net salary, so gross salary minus taxes, right? Or the opposite of that number, right? If you did 10% taxes, it'd be 90% salary. Any way you want to go about that arithmetic is fine, right? Both calculations will work identically. If you want to take gross salary times 0.9 to get 90%, great. If you want to take gross salary minus the taxes that you've already calculated, great. You'll get the same result, thanks to math. We love math. Okay, that's our lab exercise. So nothing too crazy, but some practice asking the user to enter values, converting them, doing some basic arithmetic, printing the results back out. Okay? That's what we're going to work on for the lab exercise. All right, and then our first project then will be a little bit more interesting. So, where am I? So next week we'll get to conditionals. We'll need to use some of these to finish the project. It'll be really boring without them, and basically at the calculator. So it'll be slightly, if you want to finish it this week, you could read ahead. Or you can watch Dr. Severance's videos, or you can just wait until next week. You can do most, half or so of it before now, but we'll need a little bit. I'll try not to do that very often. Usually you'll have everything you need for the project, but this is only week 2, and we've done, like, this is Python Hello World, and now, like, some variables. So this will probably be the only time we're going to use something from the next week for projects. So I want to apologize in advance. It won't be too bad, I promise. Okay? All right. So this will be project. How did I name that? Did I name it? Did I call it 0 or did I call it 1? I can't remember now. I think I called it 1. Yeah, project 1. Okay, project 1. Sometimes I start with 0. It's a programmer joke, but that's okay. So this will be 10 points for projects. Now again, the points only matter in their category. So because the lab is worth 10 points and the project is worth 10 points, doesn't mean they're worth the same overall. Right? The projects make up 30% of your overall score. The labs only make up 10%. So the points only matter within their category. So of all the 4 projects you do, this is 10 points out of the projects category, which will make up 30% of your grade. It generally makes life easier, but sometimes, okay. If it doesn't make sense, just ask me after. We'll be okay. So do in 2 weeks then, before class starts. Oh, but not the 30th, right? Because we are off for Memorial Day. So it'll be 6/6. It'll be due. So we got a little extra time. We get the whole week off. I just assume you do nothing that entire week, because why not? Memorial Day, we took the day off. So let's do June 6th for that, before class starts. Sorry. That's probably my sugar. Yes. There's no sugar in Diet Coke. Come on. Goodness. All right, the high sugar doesn't affect me as much, but it'll kill me slowly, so I'd like to not have high sugar. All right, so let's make another assignment here. So we got lab 1, and then we'll do project 1. 31, summer 2022, project 1. And I have to click all the same buttons, but that's okay. It's not too bad. Mesky, click on template. Great. Please submit the URL to your main.py. So again, each of these repositories, when you clone them, will make a separate folder on your computer in your GitHub repository, and that's okay. That'll help keep things organized for you. So you'll get a folder for lab 0, you get a folder for lab 1, you get a folder for project 1. That's okay. They'll all be separate, and they'll all be separate repositories. So if you make a change in lab 1, you won't see it if you're in your GitHub client looking at project 1. So here's the rest of the night. All right. So for this one here, we're going to be a little bit more interesting. Not a lot here, but a little bit more interesting. So we're going to write a little program that helps someone build a fence and pick out the right supplies for their fence. So we're going to write a Python program that helps the user buy the correct amount of supplies to build a fence. Okay? So we need to ask them some information for building their fence here. Excuse me. So in order to do this, we need to know the dimensions of their fence, right? We're going to assume it's a rectangle because otherwise it's a lot harder. So we'll assume this is a rectangle. Rectangular fence. Ask for the length and the width. Okay? So, and that's two separate things. You can't say enter the length and the width and get one number, right? So like ask them for the length and then ask them for the width. But I'm just trying to save a little typing here, if that makes sense, right? And then we're going to need to ask them how far apart do they want their posts to be. So if I have a 10 by 10 fence and I want posts to be every 2 feet, right? That means I've got one corner here, 2 feet in the post. I've gone 2 feet, 4 feet, 6 feet, 8 feet, 10 feet, right? That wasn't 10 divided by 2 number of posts, right? Because you started with the post here at 0. So you have 0, 2, 4, 6, 8, 10. 6 posts, right? So the arithmetic is not necessarily as so straightforward, right? Does that make sense? Okay.
Is that
Of the rectangle.
of
Yeah, so the length and width of their fenced area. So, 10 feet wide, 20 feet long or something. Or, is length always supposed to be longer than width? I feel like I'm bad at geometry. But we don't care. Whatever it happens to be, that's okay. Now, if I have a 10 by 10 fence and I say I want posts every 3 feet, that's okay, but it's not going to work, right? Because I'm going to have a post at 0, a post at 3, a post at 6, a post at 9, and then a post at 10. They're not always 3 feet apart. So that's not going to work out well. So we need to check the user's math here. And that's when I say if it's not going to work out, that's a conditional. We'll talk about that next week. I can literally put in my code, hey, if this is true, do this. If it's not true, do this. And we'll get to that in week 3. Don't worry too much about it right now. So we need to check to ensure that the distance is evenly divisible by the visible post distance. We'll do that week 3. So don't worry too much about that part right now. So you don't have to do the sanity checking and tell them that they're dumb. You wanted a 10-foot fence. You can't have posts every 3 feet, right? We'll get to that part after. For now, we're going to assume they're going to give me good values. So I can either do 2 or I can do 5. Or I can do 10, I guess, right? I can have posts 10 feet apart. If it's 10 by 10, there would just be no middle posts, and that's okay, right? Okay? So now we know the distance and the posts. right? So we're going to calculate the number of posts we need to buy. Okay, right? That should be the basic arithmetic with ever so slightly tricky. And right, once you buy one corner post, you don't need to rebuy it for the other corner post, right? So if you say, okay, on this length of 10 feet, I need 6 posts, and on this length of 10 feet, I need 6 posts, you don't need 0 and 10 for the widths. So a lot of different ways to tackle that. Any way you want to go about it's okay, right? Not too big of a deal here, right? I'll let you work that math out. Again, not crazy math, right? We're not doing anything advanced. This is just like basic algebra sort of things. If you are struggling with the math, please let me know. Like the goal is not this is math class, right? It's problem solving. I want you to problem solve and take that as like, hey, this is something I have to figure out. But if you're hung up on the math, just come talk to me, right? I will help you with the math, I promise. Right? The goal is not for you to be like, oh, this is crazy, I can't figure it out. It's, well, how do I take a hard problem and break it down into small steps so the computer can do it? Okay? So number of posts to buy. Then ask the user how long of a board they want to buy. So boards come in different lengths, right? A standard 2x4 is 8 feet long, or probably not even 8 feet because they're probably like a quarter of an inch somewhere, because a 2x4 is not actually 2 inches wide by 4 inches wide because reasons. I watched a YouTube video about it because I got down some weird rabbit hole, and that was fun. But we'll ask them how long of a board they want to buy. So if I want to buy an 8-foot board and I have posts 5 feet apart, I can take an 8-foot board and I can cut it into a 5-foot section, and I'll have 3 feet that I have to throw away. That's not a good size board to buy, but I'm welcome to buy them if I want, right? We're just helping them buy the right number of supplies. We're not helping them save money, right? That's on them as a general contractor. They need to figure that part out themselves. We'll just tell them how much to buy, okay? So how long of a board they want to buy, right? If the board length is less than the post distance, tell them they can't do that, right? If I have post distance of 10 feet and I want to buy an 8-foot board, I can't do that. Game over, right? Okay so far? Right, then we're going to calculate the number of boards needed to, it's not circle, surround, cover, build, what's the right term here? Build the fence, right? So if I buy an 8-foot board and I have posts every 2 feet, we're going to assume that like fractional bit of saw doesn't happen and that you get exactly 4 2-foot sections, right? We're just pretending here. I know you actually lose a little bit to the saw, to sawdust, but forget it. We'll say, okay, posts every 2 feet. I can cut an 8-foot board into 2-foot sections. Great. I get 1 section, 2 section, 3 section, 4 sections. So I can get 4 sections per board. How many boards do I need to buy to surround that 10 by 10 area? Right? Well, I need to know how many distances I need to fill, right? If I have posts every 2 feet, I've got one at 0 to 2 is 1, 2 to 4 is 2, 4 to 6 is 3, 6 to 8 is 4, 8 to 10 is 5. I need 5 pieces of 2-foot board to get across each one of those 10-foot sections. So I need 5 times 4, right, because they're each 10-foot sections. So I need 20 pieces of board. How many 8-foot boards do I need to buy to get 20 pieces of board? Well, I know each board can be cut into 4 pieces, right? So 20 divided by 4 pieces, round it up, right? Because you can't buy half of a 2x4, right? But that one rounds easily, right? It's 5 boards. I need 5 boards to cut into 4 pieces to get my 20 pieces. Now that was easier, right? If I had a 12 by 20 fence and I have posts every 4 feet, right? And I want to buy 10-foot boards, the math gets a little harder, right? Because we have pieces we're throwing away of every board, the 2-foot sections, because we can fit a 10-foot board into 2 4-foot sections, right? Cut it into this section, cut it into this section, throw away the extra, right? So I only get 2 sections per board, and I need, how many sections do I need? Well, if it's 12 by 24, right? I have from 0 to 4, 4 to 8, 8 to 12. I have 3 sections here, right? I'm going to have 6 sections on the other ways, so I have 6 and 6 and 3 and 3. It's 12 plus 6 is 18. I need 18 sections, and I get 2 sections per board. So I need 9 boards, right? Yeah. Yeah. Yeah, drawing this is very helpful, for sure.
Concept of board, why are you cutting it? That's what my question. So we are drawing a fence, right? I mean, we are building a fence. So
Yeah.
1, 2, 3, 4, 5, 6. Let's say. Now, when you say these are dimensions of my.
Yep.
Okay. Forget about this part. This one only. So when you say board is the horizontal board which you put in out here.
Yeah.
Now, why if I get 8 feet, can I just not use 8 feet out here and just add 2 feet? Why are you cutting it into 2 feet? I just want this.
Yeah, I mean, yeah. So okay, so you'll take an 8-foot section to cover 2 posts without cutting in the middle.
Right.
Sure. I think the math on that might be trickier, just the way I'm thinking of it in my head. Right, but if you take an 8-foot board and put it, or you take a 10-foot board, cut it into an 8-foot piece, it covers 3 posts. Right, it covers from 0 to 4 to 8 in a single piece. Sure, but then you would need to cover from 8 to 12 with a 4-foot piece. So I think math-wise, it'll work out to be the same.
So those boards need to be cut for each fence, and I mean, how that's what the confusion is. I mean,
Yeah, if you don't want to cut the 8-foot board into 2 pieces, that's okay. An 8-foot board can cover 3 posts. That's perfectly fine. The math should work out the same, because whether or not we cut the board or not.
At the bottom, is that what it is? I mean, how many of this top and bottom?
We're about to ask them next. Yep. So calculate the number of boards needed to build the fence with a single board across. Right. Then we'll ask the user how many boards they want to run across each post. So I live next to a horse farm that's actually underneath power lines. So it worked out really well for the horse farmers to get all this land that DTE or ITC says, yeah, they can use. I don't know what their whole agreement is, but like they just get to graze in this giant area because it's underneath the power lines that you can't do with anything else. But they have 2 sets of boards because they use these really wide, skinny boards. So they have 1 board at the top level, 1 board at the lower level to keep the horses in. Sure. I don't know. Other people have those pretty fences. They're like slat logs or something that they'll cut the logs to. There's lots of ways to build a fence, but we'll ask how many boards they want to run across each post. If they say they want to do 4 boards, sure, we'll just take this number, multiply by 4. So just a little bit more arithmetic here. So we'll output the total number of posts required. Oh, and then we need to ask the user how much each post costs. Ask the user how much each board costs. And then we'll output the total number of posts required, the total number of boards required, the total cost of each, and the grand total for the project. If we wanted to, we could get into nails and things, but again, if you can do these 2, I don't think we care about how many nails it takes per post and all sorts of that fun stuff. So I think this will suffice for the first project. So again, we can't really do these conditionals yet, where if they say they want 4-foot posts or they want 10-foot posts and they want an 8-foot board, it doesn't work. We don't really know how to tell them that yet, and that's okay. So if you always give it good input, it will work without any of that. So next week we'll look at if they give me bad input, what do I do with it? So you can get most of it done, okay? Right, this evenly divisible, we'll do that week 3. This totally can't do that again, week 3 content again. Okay. Other than that, we should be able to calculate all these things for them, print out the number of boards, number of posts, calculate them here, figure out the total cost, the grand total for the project. And now we've helped our contractor friend be able to purchase the right number of supplies to build a fence. That make sense so far? All right, now a rubric, right? So again, you get points for doing things. So let me add a rubric here. This is for project 1. Now, I don't like this whole like scale here. So either you did it, it's complete, or it's missing. You didn't. Now, you are welcome when you are, because what I'm going to ask you to do is to evaluate yourself. So you'll turn in the link to your file, and then I'll say, please score yourself. Right? That's your reminder to go look at the rubric and like, okay, I did this, I did this, I did this, I did this, I did this. And if you got it most of the way there, but you couldn't quite figure it out, hopefully you asked me. If you didn't have a chance to ask me and you're like, okay, I don't care, that's fine, I got it partially done, give yourself some partial points, like if it sort of works, or like, okay, that's sort of, I'm okay with partial points, okay? I might not take them, but generally I'll give you partial points if like you attempted the thing at least, right? You'll at least get like 1 point or something. So this is asking the user for the dimensions of the fence, that's length and width, right? And then asking the user for post distance, and board size. So asking for some of the things is 4 points out of the 10. Just if all you do is ask them the questions, you don't do any of the arithmetic, you still get 4 points, right? Again, we're just doing this piece by piece by piece. Now we actually have to start calculating things here. We'll calculate the total number of posts needed. We'll calculate the total number of boards needed. Excuse me. And again, partial points, if you calculate it, but you did it wrong, I'll still give you partial points, right? Because you calculated, you tried. So you at least get 1 out of 2. If your calculation is wrong, though, you won't get full points. Is that fair? So, like, if you just say number of boards divided, I don't know, like, divided by 10, or I don't know. If you come up with something, you at least get a point for trying it, okay? I really try for partial credit. And then this is calculate total cost of the project. So 10 points then broken up here. Asking the user for dimensions, asking the user for board and size, calculating the total number of posts, calculating the total number of boards, and then calculating the total cost of the project. This is both input and calculations here. Right, this is input and calculations. And so you have to ask them for those, how much does the board cost, a post cost, and then calculate. But that's like the most straightforward one. That's some really basic arithmetic, because you just use your number here, times whatever they typed in. We okay? So that's 10 points.
Question regarding
Yeah.
board size. I can go to a Home Depot or a Lowe's. I go to one of my lumberjack friends. We're giving complete 10 foot.
Sure.
I got a complete board, so that question is irrelevant. There's
So-
no board size there.
Well-
I got exact 10 feet.
So if you want to buy if you're going to make a 10 foot by 10 foot fence and you buy 10 foot boards, you still need to calculate that you need 4 boards. Sure.
Okay.
Right. If you make a 20 by 20 fence and you buy 20 foot boards, you still need 4 boards. Sure. You've calculated something.
Okay.
Yeah. So they can say they want to buy any board size we want. It doesn't have to be limited to the Home Depot sizes. Yep. Yeah. And that's a good way to check if your program's working right. Right. If I say I want a 20 by 20 fence and I give you 20 foot boards, does it tell me I need 4 boards?
Okay.
Right, that's actually a really good way to sanity check this here. Or if you say you want 1 foot post distances and you buy 1 foot boards, well, that should be the perimeter of your fence, right? For another sanity check. So there's lots of ways to test our program as we're working on it to make sure it's doing what it's supposed to do. If buying 1 foot boards with 1 foot posts doesn't give you the perimeter, you've done something wrong, right? If building a 10 by 10 fence with 10 foot boards doesn't tell you 4 boards, you've done something wrong, right? So those are good values, good ways of thinking about, is my program doing what it's supposed to do? All right, so we attach that. The overall score thing at the end is silly. Don't worry about it here. So we got project 1. All right. Oh, I didn't give it a category. Sorry. Let me edit that. That should be the projects category. Projects. Now for the self-assessment and a self-assessment using the rubric, it'll show you the rubric, but like you can't actually click on it. When I grade using the rubric, I can click on it, which is really nice. So when I ask you to give yourself a self-assessment, you could say like, for number 1, I got 2 points. Number 2, I got 2 points. Number 3, you could copy paste each line in. You could just something more than I got 10 out of 10. Like I would like for you to take a second and look at each of those 5 criteria. And like, that's your chance. Did I actually get this part done here? Okay. So that's our last sanity check. And then when I'm scoring it, I don't necessarily take your score, but generally I'll look at your score and then I'll either agree with it or disagree with it, right? So if you gave yourself partial points, I'll go look at those places you said you need partial points and all sorts of that fun stuff here. Okay, so the salary calculator is our lab exercise. Just ask for hours, ask for wage, do the multiplication, figure out the 10% taxes, print total wage or gross wage, taxes, and then net pay, right, which is gross pay minus the taxes. That's our quick little practice doing some input-output calculations. And then project 1, you're welcome to get started on as well. Again, labs are great as partner exercises. Projects should be individuals. You shouldn't need to Google anything. If you want to go Google something, great. Just go cite your source, okay? Find me, just put a little comment in, say this is where I got it from, right? Like, I think we did it here. I don't think we did any of that anyway, but that's okay. Right, just leave it as a comment and we're okay. All right, questions, thoughts, or concerns? Yes.
So it's not a format to test all places, or to respond to
It doesn't need to be formatted at all. We'll talk about the formatting a little later on when we get more into talking about strings and things. Formatting is a little bit more advanced. Yeah, so if it comes out as like 6.66666, that's okay. Again, this should be like whole numbers of boards though. So most of this stuff should be whole numbers because you can't buy 2/3 of a board.
Oh, no, I was talking about the in-class one.
Oh, for the in-class lab, yeah, just let it be ugly. Yep. Yeah, if you want to format it, there's a way, but it won't make a whole lot of sense yet. And there's like 7 different options for doing it. So I usually wait till a little bit later in the semester to cover that sort of stuff. All right. Awesome. So I'll end the stream here. If you folks online want to meet up, just shoot me a message in Discord or email me. I'll put you in the queue as I walk around the class, and we'll go from there. Thanks, everybody.